Good evening, YouTube. Here's an update on the MQTT wall controller project. It's 1:38. I've had a few plum wines, and I'll show you what it looks like fully assembled. Join me, if you would, in a celebratory glass of, what's this? Takara plum wine. Anyway, because it's been a year in the making, and here it is. It's finished. No, that's me. It's finally finished. Here is my wall controller project. Proximity detection using the MPR121 proximity detector. What I'll do now is I'll give you a really quick demo because you've seen it all a million times before. This is how the project started out about 12 months ago, based on an Arduino Nano, and then I was going to have three little preset buttons and one rotary encoder. Well, it outgrew the Arduino Nano's memory, program memory limitations, and the SRAM for that matter. The project grew and grew and grew, and now it's based on Arduino Mega, because the sheer amount of code that has gone into this it would only really fit on an Arduino Mega. So that's what I'm using, and of course the whole thing fits in a 47mm back box. So I will start by, proximity sensing has broken. That's a bloody shame. Never mind. I'll explain to you why that is in a minute. But I will start by just quickly demoing the functionality. We've got all the presets for whatever mode you're on. So I'm on lighting mode. It defaults to lighting mode. I turn the lights up full, and the lights have gone up full. I turn them off using the all off button. They've all gone off. I use Lightwave RF switches, but you can use any switch that will hook in with OpenHAB, and that will work fine. Of course, you've got individual control of your light circuits. We can cycle through up to 6 circuits. I've only got 2 defined in my bedroom for testing, but we can up and down the light circuits there. Move on to audio mode. These are presets that I've defined. I'm using Squeeze Server, but again you can use Sonos or any other system supported by OpenHAB. And let's see what happens when proximity's back again. Let's see what happens when I hit on World Service. You can see Google Voice is employed to say the words BBC World Service, and it switches on to World Service. Interesting. Back to Radio 3, I think.
Radio 3.
Lovely. Through the Night, that's the show playing. And the volume, let's turn it up. Oh, lovely. Very lovely indeed. And then we've got temperature mode, which I've not finished programming yet, hence the all off applies to that mode, and it shouldn't do because that's obviously silly. And that's the actual temperature outside. That comes from Yahoo Weather, but we're going to change that eventually to the current room weather. Proximity has died again. I'm going to show you why that is. Anyway, all the different modes, all the different things that you can control. I'm now going to take the thing apart so that you can see how it's constructed. But for that, I'll need my faithful assistant to come and hold the iPhone. Before I do take it apart, I'll just quickly show you that I can reboot this thing. That's the wrong one. Oh, it's this one. Double press. Yeah, I can reboot this thing from the interface itself. This is my reboot sequence. Getting the IP address over DHCP and getting the zone name from OpenHAB. All the subscribes are happening. That's the OpenHAB console, and we're in. I'll show you that again. Let's do a reboot. Night Rider. Getting zone, downloading all settings, and here they are. All of that data comes from the server. Anyway, here we go. I'll take the thing apart. So, first of all, these things come unclipped like this. Oh, forgot to take the knob off. Got a bit of a wonky knob. And that just comes off. That thing there, by the way, that you can see is a blue lighting gel, which I've sandwiched between the layers of the back plate and the front plate. to give it that kind of blue hue, but also it's designed to kind of so that you can't really see what's going on in here, because there's a bit of a gap between the actual display and that just kind of, I don't know, it seems to be make it look a bit more professional anyway. So that's that, and that's the water jet cut faceplate. Ta-da! So let's take this thing apart. First of all, I'll start with the screws that hold the whole system into the 47mm back box. That is the largest, or rather the deepest back box that money can buy, at least in this country, at least for off-the-shelf back boxes, as opposed to kind of custom-made ones, which I didn't want to go down that route, really. I know people like Crestron and Lucent, Lutron, in fact, have gone down that route, but I'm not into that kind of money. Frankly, this thing costs about £1.50 from Screwfix. And here it is. Here is the fully assembled, I'm grabbing the phone so we can see. There is the fully assembled system. On there we've got, and well, I'm just going to show you get the light down a bit closer. In here, how can I do this so that we can see? We have some foam, sticky back foam to stop the Arduino shorting out on the back box. That's the Arduino Mega. Sandwiched in between the Mega and my custom bottom board there, we've got this focus. We've got this W5100 board, which I'll show you in more detail, with some dodgy spliced Cat6 cable to provide power over Ethernet. That's the bottom board. That's the top board. That's the button board that lays directly on top of the top board, and then that's the controller button board on the top. But yeah, I've taken the kind of Arduino shield approach with this one, so it all fits together. So that's that. And now, hopefully my lovely assistant is going to come back and help me. Oi, can you help me? Thanks. And I will take, where's my screwdriver gone? Right, I'll take this thing apart now. So you can, yeah, that's what happens when you get one-handed. There you go. There we go. No, I'm screwing and nothing's actually happening, as I need to actually pinch this. There we go. So I'm using hex spacers, which are very common in computer PCB. Oh, bloody hell, come on. Here, love. Come on. I can't bloody get the bloody thing out. What's going on? Oh, pile of shite that. Oh, fine, we got it. Don't worry, it's coming out. And there we go. Let's pull that out. Oh, by the way, just quickly show you, you can't see because it's very close up, but just if you kind of point the camera here, there's a tiny little, I've pressed the button and turned the lights on, there's a tiny little bit of metal that pokes out of there, and I'll show you what happens when we press that metal after these lights go off. Wait for the lights, there we go. If we press that bit of metal there, boo, that brings the lights on, and that actually couples the front plate to the proximity electrode, which is that thing there, that little wire there, and that goes into the thing called prox, but I'm going to show you that in a second. That's soldered on and kind of dodgily glued in there. I don't really know how better to do that, but I've used a spring connector and it's kind of come undone a little bit, so that's why it's a bit unreliable. This, I have not actually put these, you can see I've butchered this faceplate because this is a test faceplate and the holes were in the wrong place anyway, and I got it cut at the Waterjet Cutting Company, and they had the old designs where the holes were in the wrong place, so I just kind of manually routed out those countersink things, but we're not going to talk about that. Otherwise, what we would have is we'd have a screw there and a screw there holding the these things to the front plate, the back plate, and then we'd have screw there, screw there, screw there, screw there, and that would work. But we haven't got those four on now, so and that is what it looks like. Very pretty, don't you think? I think it's very pretty. think it's rather sweet. I'll turn the lights down so you can see it. Ooh. Oh, look at that. It's pretty sexy, isn't it? Oh yeah, that's nice. Anyway, so that is the whole thing. Right, let's turn the lights back on so we can see what's going on. Lovely. And I'm going to just pull the display off. And that's a reset button. As you can see, I just pressed it. That is our LM, what is that? The LM1117, which is a 3.3 volt linear regulator. This is a teeny weeny little board bought on eBay. I think it's a copy or clone of a board by SparkFun, or even by Adafruit. I'm not sure actually. Anyway, very, very cheap on eBay, and it basically converts 5 volts down to 3.3 volts to power this display here. So I've got, obviously that does that as well, but this provides the signal conversion, step conversion down to 3.3 volts. This thing here is the MPR121 touch sensor, and that's what that does. And unfortunately I can't take these button boards off because they're soldered on, but I can take the whole thing off. There you go. Basically that is the top board. Can we get a fix on that? Get a bit closer. There you go. That's the button board, and the top board. The two button boards. This top little thing here, this bottom little thing here, and then this top board. I call this the top board as opposed to this thing, which is the bottom board. And then I call these the button boards that lay on top of the top board. This thing here is a buck converter, which will convert down from my 20 volt power supply coming through the Cat6 cable from the Dell charger that I'm using, or 19.5 volts. It supplies a wonderful 6 amps plugged into an 8 way kind of patch. What am I trying to say? It's a power injector. It's an 8-way power injector. You plug one Dell charger into it, and it will provide 8 of these things with enough power. I think this thing is only using about 500 milliamps in total. Anyway, there it is. PoE comes into these block connectors here, but we can just take the Arduino out. I'm going to pull without bending the pins. There she is. Still powered, obviously. The Arduino is now not powered. So that is the general gist of the whole thing. I'm going to put the whole thing back together again. Like this. You have to kind of line these up like that really gently and just make sure everything goes in. I've soldered this quite well, I think, so I don't need to worry about bending pins too much. Just pushing it usually works quite nicely. It doesn't go in all the way, but these do go in all the way. That goes on there. This puppy goes on here. Let's just do that again. Get these two in. As you can see, I'm not using all of the Arduino pins. Can you see? I've only got I've got these header connectors here, but I've only got those pins. Anyway, so I'm not using them all. So just wang that in there, wang that in there. Bosh. That reboots for some reason, probably because this thing was, I don't really know. And whack the old screen back on. With a bit of luck, it's going to work, innit? Alright, what we got? Doesn't work. Let's hit reset button on it, shall we? You've locked the old focus there, love. Right. Yeah, there you go. Reset. And as you can see, when it resets, this happens. Thanks, Anna. Right. Did you see what happened? I'm just going to pause the output for a second so I can show you what happened. So here, the controller sent OpenHAB this controller setup state. And what did it send? It sent this message, deed Batherfeed. That's the MAC address of this here W5100 that I've set it to in code. That's the MAC address. So the controller sends the MAC address. Sorry about the focus. Let's try and get that right. Controller sends the MAC address to OpenHAB. OpenHAB responds by saying, because it's expecting that MAC address because I've set it up ready for that MAC address. saying, ooh, controller of deed buffer feed. I'm going to give deed buffer feed a zone vector of bedroom, and I'm going to give deed buffer feed a zone name of lower ground bedroom, and deed buffer feed a zone sense of 5. That's the touch sensor proximity sensitivity that I can set remotely if I want to, but I don't really use that. I just kind of leave it on that number. But yes, so this thing here, the zone vect bedroom, is different from this thing here, LG underscore bedroom. That's the zone name. It doesn't really do very much, the zone name, but the zone vect is sent from OpenHAB to this device, and then this device uses that zone vector to form its MQTT vector when it reports back or expects any communication from OpenHAB. So that actually forms part of the path, the MQTT path. And then what happens, bedroom vector state updated to circuit count please. So OpenHAB is asking for how many circuits are there in the room. OpenHAB knows because it's the number of items in a group, and it says, right, well, there's 2 items in that group, so there must be 2 circuits in the room. Bedroom vector state updated to circuit names, please. So it says, right, I've got 2 circuits, now what are their names? Circuit 0 is called ceiling, circuit 1 is called wall, and then it says, right, what's the light scene 1 name, please? Oh, that's sleep. Light scene 2 name, please. That's bedtime. Light scene 3 name, that's reading. Light scene 4 name, that's working. Light scene 5 name, that's full. And those correspond to these things here. So I've obviously set those in rules within OpenHAB, and you can just change those as I like. And if I want to, I can actually reboot this thing or re-download the settings, and I can initiate that process from the web interface. Oh no, not that web interface. This web interface here. I can reboot the panel from here. I can update it. That doesn't do anything at the moment. That's my proximity thingy. But anyway, bedroom. I have no idea what I was showing you just then. My memory's like a sieve. Anyhow, back on to OpenHAB. That's not the right window. Sorry about that. Where were we? Yeah, so we've got all the light scene names, or similarly with the audio favourite names, Radio 3, Radio 4, World Service, etc. Then it asks for the date time, which is also updated every 15 seconds or half a minute or something. And then that gives us back the date time from OpenHAB. And then it says light scene please, and light levels please. And it says the ceiling state is 100 and the wall state is 100. That's what it was when I turned it on. Now, if I had changed that from the iPhone or elsewhere, that would obviously report differently, and it would show that at startup. So it would show a different set of numbers at startup. And then where are we? So yeah. Bedroom state updated to volume, please. So OpenHAB is asking for the volume. It's saying the volume is 10. And it's asking for the play pause status, and it's saying it's 1, which means it's playing. And then bedroom oh right, I've missed all those things now because it's going to start scrolling. Anyway, you get the idea, that's what's happening. And then we've got this bedroom temp MQTT state updated to 17. So that is every time there's a reading taken from this temperature sensor, which is this little thing in here, that gets sent to there. Now, this is not designed as a room temperature sensor. The reason for that is because it's going to get very hot in there. Well, hopefully it's not going to get too hot. In fact, the idea of this sensor is so that if this thing overheats so much that it burns your house down, it'll send you an email, which is really handy when you haven't got a computer anymore. But anyway, that's the idea. There's some kind of ability to put in some kind of auto temperature cutout thing there in case the thing burns down or gets too hot. I don't think it will, because we've only got this buck converter in here, which is getting slightly warm, running at kind of 96% efficiency, and then this LM1117, which doesn't really get very hot because we're not driving it very hard at all. This display doesn't get hot at all. It's completely cool to touch, and those are the only things that get hot. But I'm a bit of a paranoid person, so I put that in because I wanted to know if this thing goes above, 30 degrees or something crazy. So that's it. That's the system, the whole thing. I will leave you with this picture here. Ta-da! Thanks very much for watching. I'm very excited about my new project. It's all but finished, and now I've got to do the code updates to make it a lot better than it is. And if anyone's offering to help me with OpenHAB, I would really take you up on that, because I find OpenHAB and Java all a bit of a head, screw. And yeah, it would be nice if anyone could offer me some help to streamline the way that this thing communicates with OpenHAB, because I really haven't done it as well as it could be done. Anyway, thanks for listening. Bye.